Hi, welcome into my channel. This channel is against the current view astronomy. Basically, I say that we can go to the stars. The stars are small. They are not like our sun. They are not emitting flames. They are blocked in clouds. Our galaxy is a sphere surrounded by clouds. Einstein's false physics, quantum mechanics, false physics, even Newton and Maxwell are false sciences. Physics is false. Okay, so they made rockets and some engines, steam engines and engines by stupid dudes, and then they break with science, with weird science. So about quantum mechanics, you listen, I cut from some videos and I comment them. Brian Greene, World Science Festival, like about quantum mechanics. So look.
Welcome to the second in our series of conversations on quantum reality. In the first part with Elise Kroll, we reviewed the essential conception at the heart of quantum mechanics, which is that the theory is probabilistic in its pronouncements. That is, whereas Newtonian mechanics takes as input the state of the world right now and as output predicts the state of the world tomorrow, quantum mechanics takes as input the state of the world right now, but by contrast, predicts the probability that the world will be one way or another tomorrow. In a sense, then, reality kind of hovers in an unfamiliar, ghostly mixture of many possible dispositions. Particle here and particle there. Particle spinning this way and spinning that way, and so on. Possibilities captured by the so-called quantum wave function, and only upon some notion of observation or interaction does the world transition into the single definite reality of common experience.
Okay, I want to say to compare what I'm saying, what they are saying. Okay, so if you understand this, you will believe in somehow that you do not understand what these guys are speaking because they are incoherent. Okay, so about quantum mechanics, I've told you the particles do not exist already in my channel. No particle exists. There's no a single case where a particle exists when you make a short circuit, or like an electrical short circuit, plus minus plus, and you take a piece uh, of material, and you eject it. Now you can capture that, and you okay. So particles do not exist. The system particles do not exist. They are, so what is spins like this? On that experiment with they shoot laser beam, okay, or light, and the electrons you are believing somehow that exist does not exist, and energy it is light. Faraday was saying this like a little bit, okay, and quanta is light. Einstein says so, at least. If you are taking this bullshit science, okay, so quanta is light, how light is moving, okay, so through cables it is light because electron does not exist, and so watch another part, and I'll speak more.
The previous range of possible outcomes, each provided by quantum mechanics with a particular probability for happening, seemingly collapses to one and only one definite reality. Now, how that transition actually happens, the so-called quantum measurement problem, that remains an unsettled question that to this day inspires creative theorizing and heated debate. Now, the probabilistic nature of quantum mechanics famously troubled Albert Einstein, but actually, it was another quality of quantum physics, a quality that Erwin Schrödinger identified as the feature of quantum physics, distinguishing it from the previous classical approach called quantum entanglement. That is what really troubled Einstein the most. You see, we are used to a world that is local in the sense that what you do right here affects things right here. Or if you allow your influence sometime to spread, then it can affect things increasingly farther away.
Okay, if you watch that part, particle space, one like this, one like this. So I've told you even the sound is light. The sound is like the shock wave, like it hits with mass. The shock wave, like boom boom. You see, it vibrates a piece of paper. But you register sound with a microphone. It is electromagnetic coil. It is with wires like this, and your voice is impriming a frequency. So the sound itself, it is only carry on the shock wave that you are believing that is sound with the speed of sound. So you see how if you understand how the sound is propagated. You see, if you take a simple way of vibrating air like this, you see, but the sound is like a constructive thing like this. You see, so where is the collapse of the of the wave? You see, this is the collapse of the wave in a simple way of telling like this. Because this chord has all these possibilities, all these tonalities, okay? So it is a basic tone frequency and you collapse it because the particles not exist, so it is light. So but now Schrödinger could make the equation for all the music. If you understand, there's temporal procedures, and you decide you sing like this. The three accords, okay, you decide them like it is like a frequency, a tonality, the chords, okay, but you decide some frequencies, and you do not believe, you are believing somehow this chaotic life. It exists a common frequency of light to put it in like this, and to put in an equation, you know, a common frequency of light made by who? By the sun, by your TV, by your computer, by this. What it is a common frequency to put in a single equation. If you understand this psychopath science, Schrödinger, they took Nobel Prizes, they gave Nobel Prizes, one more crazy than another. So watch another part, Brian Greene. You'll see that it's totally incoherent, and they do not tell you anything. If you do not believe this, okay, watch.
But quantum entanglement shows, by contrast, that there are situations in what you do right here can instantaneously affect something far away. In particular, it can cause a distant object to snap out of the quantum haze of many possibilities and assume a definite disposition. Now, such non-locality, it's contrary to everything that we experience, but it seems to be an integral part of quantum reality. And as we discussed in part one, this entanglement can not only link objects far apart in space, but also far apart in time.
So now, if you understand how light propagates, but it is an infinite field somehow. You see the first three accords, I play them in another manner. You see there is a Solomon book, only the Orthodox have it. It says that the elements of the world are changing between them properties, like an instrument with chords, not with like a flute, with chords. It says each changes the measurement, but it keeps the tonality. You see, a tone, a basic tone like the, but then you make frequency. You see. So what I'm telling you, light itself is like this. If you understand. So this the tones are somehow infinite. If you understand like this, there's a do no like this. and if you take all the Mendeleev, let's say there is a do note for all the elements, because each one gives the different kind of tonality. But now you do not understand that you do not understand that you cannot make the equation, because you see how I've told you in one video, the reality is packed with light. You see, is like, so watch another part from them, and I will speak more.
All right, that was part one. Let's now continue with my second conversation in this quantum reality series. This is with physicist Sean Carroll, and he is one of the strong proponents of Hugh Everett's 1957 proposal called the Many Worlds Approach to Quantum Physics, which, as we shall see, will give us insight into the quantum measurement problem and possibly even into this issue of non-locality with quantum entanglement. All right, let's go. Sean Carroll is the Homewood Professor of Natural Philosophy at Johns Hopkins University and an external professor at the Santa Fe Institute. He is a best-selling author about the foundations of quantum mechanics, as well as the host of the podcast Mindscape. Great to you. All right, so you may have heard a little bit of our conversation with Elise, and I just want to jump right off from there and trying to get your thoughts on the quantum measurement problem. Then we'll look at one or two possible solutions, focusing upon the one that you think does the best job. But how important is this measurement problem, and how would you even frame the problem?
Actually, before I even answer the question,
Please,
it occurred to me while I was listening to you and Elise, you've picked people for this program who care deeply about the foundations of quantum mechanics, which makes perfect sense. An hour from now, there'll be another program featuring the great minds of string theory. I would love to know what they think about the importance of foundations of quantum mechanics.
Well, actually, it is an interesting question, because I think, as you know, many physicists don't talk about the foundations of quantum mechanics. And you're right, it could be somewhat misleading to have a program where people care about this issue. So why is it that it isn't something that's grabbed the community perhaps as fully as we think it should?
You know, I think that we all agree that quantum mechanics is super duper important to our understanding of the universe. It's the best, deepest understanding. It's the framework in which we have to work. But you can get by making predictions and fitting data without digging too deeply into the foundations. And I think that physicists are fundamentally pragmatic people, right? And I think that throughout the 20th century, the attitude was it's hard to see how to make progress on this problem. It's hard to say, let's build a particle accelerator and solve the measurement problem, right? So they tackled other problems, but
okay, if you watch that, I wanted to tell you, this is the way I make videos. I cut from other videos, I commented. You see, the electron does not exist. You see, the color, it is mixed here. The color, it is light, here appear like red and blue, and you see, it is mixed in this orange juice, okay? But what you do not understand, so there's probability. What is probability? So what it is probability? Like if you have this you see, you have 1 to 6, so this probability to give, it is a probability to put the brakes here or here or here or here. So now you define this chord with a single tonality, like and many tones, like semitones, like not physical tones, like a music tone and semitones. Okay, so now if it is a tonality and you cut it, you put a stop. There is in this chord this tonality. Okay, but you do not understand that the reality is made like in a rational type manner. So watch another part and I'll continue maybe. This I will tell you, quantum stupid bullshit. Okay. So I have 16 particles: boson, proton, neutron. bullshit science. Okay, to interdict us to go to the stars, man. To understand the stars are close. They're small like this. They are stars like this small. The galaxies are simply stars, clowns in our spherical galaxy like this. put on the wall, like spiral. They don't go anywhere. So watch another part from, and I will speak. See me in my next video then.
I don't want to push this too far, but I think that there's a point where in fundamental physics, we have very difficult problems that we're stuck on right now. And I would argue that maybe that's because we don't understand quantum mechanics perfectly well.
Yeah. Now, there's been a lore or a phrase that is often bandied about by those who don't have any interest in, say, pursuing the measurement problem, which is basically shut up and calculate is the approach. Just use the mathematics of quantum mechanics, make your probabilistic predictions, go out and test them in the laboratory. If it says the electron 30% here, 70% here of the time, you should find it here roughly 30% of the time and here 70% of the time, and you do. And for some, that would be enough. But for you, clearly it's not. And for me, it's not either. But what then drives you to dig deeper?
Yeah, I've noticed that these folks are actually very good at calculating, less good at shutting up. But we can all do both. I think there's room for all of it. And to me, it's this wonderful, delicious puzzle that nature has given us. Quantum mechanics is totally different than any other theory in physics. Before we had quantum mechanics, there was, as you mentioned at the start, this paradigm handed down by Isaac Newton. There's stuff, there's bottles and tables and baseballs, and then we have equations that say how that stuff evolves with time. And that was it. You had those two ingredients, and maybe it's electromagnetism or gravity or whatever, those two ingredients. Quantum mechanics comes along, and you have those two ingredients. Still, you have the wave function. That's what replaces bottles and tables and things like that. And you have an equation that says how the wave function evolves, the Schrödinger equation. But then the rules don't stop. There's extra rules. And the extra rules all have to do with measurement.
Yeah.
When you measure the thing, you can't predict what it's going to be. There's a probability for getting different measurement outcomes. The wave function collapses. That is completely new in physics. And so what exactly is going on? I will go so far as to say the current textbook understanding of quantum mechanics is clearly unambiguously insufficient as a fundamental theory of physics, because it says things like, when you measure the system, something happens. And if you say, what do you mean by measurement? It says, oh, we can't tell you that.
Yeah.
We got to do better than that, right?
Yeah.
Okay, if you watch that, you see light is mixed. You do not believe in this orange juice. But what I'm telling you, the orange is if will be in a brutal manner to taste all of them like this, oranges. Okay, to taste all of them like this. It is not a joke because it is made with light, okay? This color is showing to you that is light in the mixture. Electron does not exist, I'm telling you. From TV, they shoot a beam of light in some membrane to produce, and that's why they're tricking you. And from maybe like medical scans, okay? But it's still light. There's a frequency of light. But now why do you cannot make an equation? Listen why. You see, the orange juice is infinite. It is infinite, like somehow. You see the light here. It is yellow. Now because it is dough, like this dough. But you do not understand there is dough, flute dough, piano dough, this guitar dough, and many instruments. How many can you think of them, okay? So now imagine there is a dough note for each Mendeleev, but in what case? In what case of frequency when you hit them with light, okay? So now you understand that this glass is like composed exactly for this equation, for this occasion, okay? You'll not find the same frequencies and the same, this will be in brutal manner to combine some carbon, hydrogen with water and the same taste, always the same taste, the same manner. You see, you have potatoes, the different taste is the different, you see, even the smell of a flower, you imagine that it is a single frequency like this. And you smell it, the smell itself is like made in fire and with light, the smell itself, and the touch, and all those senses, and okay, with light. But and the frequency, you see, it is composed somehow exactly for this occasion, okay, if you understand. You see some frequency, special frequency, it is a low note, like a yellow color, if you understand. But the combination is going to be brutal if you put water, and it will be always the same. So if you understand it somehow roughly, if you understand what fractals are, it's so geometrical wave arrangement, individual way where you extract it from the same equation, and you cannot extract another fractal is different, like you see. So if you understand, it's going to be brutal to be like in this stupid manner, like this, and collapse of the wave. So if you understand, there's infinite manner of sculpting the air, like with frequencies in a three-dimensional manner. It is exactly infinite, okay. So if you obtain a tone like a yellow tone like this, and the light you combine with this, it is not going to be the same from another orange, even from the same tree, you see. So if you understand this, you can put roughly in the same fractal, mathematical fractal, if you want, tree, but you cannot put, okay, if you understand, okay, on short, quantum mechanics, bullshit science, and the electron does not exist, and the light itself makes all these things. Light itself is touch, and it is exactly like with frequency. You imagine you touching like this, you see the surfaces, you do not define this current day science in the correct manner, okay. It's some tonality of touching, and they are different, okay, not only with temperature, they are different, okay, on the sense or by frequencies, and so and they are infinite. You cannot understand if you do not understand. So you must understand, if a wave, it is like with these frequencies, and it is in a three-dimensional manner, you can have this in an infinite manner, okay. So you are thinking that it is simple red or something, but it's infinite. It's a tone of red, and so frequency, like music, you add this some part like this. You are believing like in this, let's say that the vibration this direction, you add to the red some vibration like this on this axis, and it makes another kind like music, another kind of accord, like you see, you add another. So you understand, it's like you sculpt a simple cylinder, but the way of sculpting is in an infinite manner. So it is this cylinder with this common medium, let's say, kind of tonality, so frequency is red, but you can sculpt it, is you see, I mean, it is. And it is not in a simple manner, only like it is a geometrical frequency. You drink it, you see it, you live it, okay. You do not see a simple color like red. I hear do note. I do not hear like a. You see, I hear do note. I see yellow. You are seeing exactly that frequency, that vibration is telling something to your nervous system, and you live it like it. There's different tonalities of yellow, and they make something. Sometimes they do not, because let's say it's missing some part of vibration, or does not have, or that's a blessing, or you do not know this stuff, okay.
And so people have tried to do better than that. It's not as though everyone is just saying we can't make any progress and throwing their hands up. People have put forward ideas. I wonder if we could just kick around a couple of those ideas. It doesn't really matter to me where to start, but how about the GRW theory, as it is called? What is that approach to trying to solve this issue?
Well, the first fundamental thing you have to ask is this wave function business. Is it a representation of a real physical thing, or is it just a tool we use to make measurement outcomes? So first, let's imagine it's real, okay? Then you have this collapse thing. Is that real? Does that really happen? Or is that just apparent? So GRW is one of a set of theories where you say the Schrodinger equation isn't always right. A typical particle will obey the Schrodinger equation for millions of years, and then spontaneously by itself it will collapse somewhere. And it would be very unlikely to see that in the case of one particle, but you have many, 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 many particles in a simple macroscopic object. So basically, something like the bottle here is kept in one location because at least one of its particles is just spontaneously collapsing and localizing all the time.
And that sort of yields a cascading effect then. Yes.
Because of entanglement.
Yep.
That particle is entangled with all the others, so we perceive this definite set of positions of stuff in the world, even though the deep down quantum theory is a little bit different.
And because there's so many particles, the odds are one of them will experience this new process that collapses its probability wave and then downfall the dominoes.
And the great thing is that it's experimentally testable and the tests are ongoing.
Yeah, and so where do we stand on those tests?
It'll be ruled out soon, don't worry. This is not the right theory, by the way. We're just being polite.
Yeah. And so maybe to cut to the chase then, what
You want the right theory?
Yeah, what is the right theory then?
Well, we've already you talked about with Elise the fact that we describe a spinning electron, which you could observe to be clockwise or counterclockwise, spin up or spin down, as a superposition, right? That's one way of thinking about what wave functions in quantum mechanics are, superpositions of possible measurement outcomes.
A blending of the possible outcomes.
That's right.
Yeah.
And so the measurement problem arises because when we look at the electron, not only do we never see it in a superposition, but we've never felt like we are in a superposition of seeing anything at all, right?
So about quantum mechanics, it is wrong, big time, okay? This is probability and you decide 1 from 6. So you can make probabilities like 1 from 10, 1 from 100, 1 for a billion, 1 from a trillion, billion, trillion, quadrillion. How do you are liking to speak? 1 of the power of 10 of the 10 of the 10 of the 9 of the 10. Okay, quanta are packets. I like this. But it is wrong somehow. It is an infinite function number like 0.1, mathematics do not apply exactly on geometry. Geometry is a world is okay, so you do not understand this stuff, you are bragging with it. Classical mechanics explain all the world and did not explain in with the orbit in correct manner. If you do not believe, they are going with flames, they do not know this. They are blowing flames to the earth of a rocket and they do not know this. They do like this. Because if you are blowing a pure force of gas, you will not go. You must burn it. They do not understand even what they did because not Newton put them on orbit but von Braun. Okay, so this is the video for today. I say to you that the stars are close. Our galaxy, the sphere is not a spiral. It's surrounded by black clouds of matter, hydrogen, oxygen, mainly, even in liquid manner. Okay, and the galaxies are not gravity is not attraction. It is a discharge of energy in a field. Okay, so not due to mass on Galileo time. Okay, because the light does not have anything in deal with light, exactly like in with mass light. Okay, so our galaxy is surrounded by clouds, and our galaxy is a small sphere with a rocket that Chinese have long march of Russian powerful rocket, or even Indians rocket, or even now Ariane 6 rocket, European ESA space agency rocket, or Elon Musk Falcon 9, or now maybe spaceship will work. We can go to the stars and to the galaxies. Believe it or not, the galaxies are simply clouds, and our galaxy is surrounded by the field of light like this, and the stars are blocked. Believe it or not, the sun itself is blocked. And all this bullshit science is recited like a dark, malefic poem. You see, and they flunk you because they do not like your face. You are looking in your eyes in the areas how they want, okay, and they flunk you to the school. I have a professor, you do not study philosophy, you do not have a face of philosopher, so 6. Romania is not from A to F notes, it's 1 to 10. Okay, so goodbye, God bless. Quantum bullshit, Einstein bullshit, and all these tricks are keep you to take good jobs and they to take you a qualifying note like stupid. You're wondering why they are shooting in schools. So if you want to remain stupid, you bullshit each other another 100 years, okay? Goodbye, God bless.